So we're here with our 6D system.
ACOPOS 60.
ACOPOS 60.
Yeah.
We innovate, we elevate, we are automate.
For me, it looks a bit complicated, and I'm used to single-axis motion, servo motors, frequency inverters, and stuff like that. And I can see there's a lot more technology in this than just a rotating servo motor. Hayo, can you explain a bit about what we're seeing here?
Of course, of course. Yeah, this is actually the next level of transport systems. As you say, you know rotary motors, you probably also know linear motors,
Yeah.
where you have an array of magnets and coils on the other side, and if you do the right current through the right coil, the thing starts to move. And this is actually the same, but then in 6 degrees of freedom. So in those black blocks, those are the motor segments. We have electronics, brains, CPU, and also the coils that actually generate a magnetic field on which the magnets that are on these little movers react and start to move.
So it's kind of like a motor you just have opened.
Exactly, yeah. So cut the motor to the center and then spread it flat.
But I have to stop you because you say
okay.
6D, but I see 2 dimensions, X and Y.
Yeah. But if you look from the side, you will see that the shuttles are actually hovering.
Yeah.
They can be hovering up to 4 millimeters, so there's air in between.
Okay, so you can also
it's
control
totally-
the height,
Exactly, it's totally contactless.
but that's 3.
There's 3. And then, so we have X, Y, Z.
Yeah.
And then there's 3 more, which is the rotations around each of those axes. So we can actually have the shuttle tilt.
Like my 6-axis PlayStation controller.
Exactly, yes.
Ah.
And it can also rotate around Z. And each of those motions can be controlled individually for each shuttle, wherever on this system.
Is it just for transportation, or why do I need a system like this?
Well, basically, if you look at the different markets where we supply the B&R products, like packaging, assembly, batteries, pharma, medical devices, everywhere you are moving things inside machines. And traditional systems have lots of limitations, like their fixed pitch or fixed timing, or only have limited speed. This is really super fast, super accurate, and extremely flexible, because at any moment in time you can decide a shuttle to go either that direction or that direction. So it gives a lot of flexibility, and it really helps to build the machine more and more compact compared to traditional solutions.
Now this is 4x4 and we have 4 shuttles. What are the limitations? Can I do whatever I want? Or?
That's actually really cool. There is basically no physical limits. You can expand the system with motor segments and shuttles.
Okay.
Up to hundreds of shuttles is really possible.
Okay.
Often it's not needed, so that's also some part of our job, to help the customer to optimize the system,
Yeah.
to have as less hardware as possible,
Sure.
basically to save on cost.
But what if let's say if I took one off, would it then I need a new program or reboot the system or?
No, that's part of the clever software. That software that we use to drive the shuttles. It's called Traffic Manager,
Yeah.
which basically helps to very easily write the program code. It almost writes it for you,
Yeah,
and you
okay.
just have to configure it. And what it does, it's station-based. So actually, if you define, let's say, in each angle is a station,
Yeah.
it will just send the next shuttle to that station. And no matter if there are 3 shuttles, 6 shuttles, 8 shuttles, the next shuttle will go. Once it arrives, you can do your process and send the shuttle away again.
Okay, because I'm thinking like servo movements, that I would do an absolute movement from this coordinate to this coordinate with a motion profile.
Yeah.
So it's nothing like that.
It's not like that. If you want that for specific reasons, that's possible.
Yeah.
But the basic traffic, the transport is all automated, and it's really station-based, and with that, very simple and easy to use.
Well, Hayo, they look kind of identical, the shuttles, but can I identify one of them if I have something special on it?
Yeah, that's quite cool. The shuttles have embedded RFID tags, so you can really uniquely identify each shuttle. So if you would add a shuttle, the system can actually identify the unique ID number of the shuttle, and you can use it to be sure that you have 24/7 tracing of whatever happens on that specific shuttle over time.
So it's also a solution after, let's say, a power outlet. If you need to
definitely.
figure
After
out
power.
where is what on the
Yeah.
table.
Yes, exactly. So that's available in each shuttles, and we now see 4 shuttles of a certain size. We have different sizes for more payload. Then the shuttles become bigger, which is kind of logical, because the bigger magnet surface, the more force
Yeah.
we can lift and move around.
Yeah.
Okay.
And if I have something special, I said only this one, I want to offset it a little bit here on the position. Is that possible to do?
Yeah. So that's the traffic manager, as I mentioned, is doing the main transport, and then actually in each process station you can write some small piece of station code to do offsets, to do small movements, to do like walking through an array, a matrix
Okay.
to do small product processes. And then once ready, you say go, shuttle goes to the next station.
So could you, now I'm just thinking, could we, I know we have a CNC core, could we, like if you had a drill, a fixed drill, could you then CNC the movement and do like a certain path or whatever it should be?
Yeah, definitely. So
Okay.
that's all those low-level commands are available, typically for the in-station operations. So instead of an XY manipulator moving a pen,
Yeah.
you have a static pen and you move the shuttle.
Yeah.
And the pen can be a dispenser, can be a processor, drill, can be anything.
Yeah. An old-fashioned drill with a cylinder here, and then you have a fully flexible
How do
system.
you call it in Danish? En boormaskine, I believe.
Yes, bore machine, that's right.
The shuttles, they are not 100% identical. What's the difference between those two?
As I explained, there's different sizes of shuttles to get more for more payload. But we also have two versions. So there's the standard one with all the drilled holes where you can mount many product holders or whatever you like. And there's a second version, the one in stainless steel, which is 100% hygienic. And we have quite a lot of customers in pharma, medical devices that want a food as well. That really want to be able to clean the system completely, to clean the shuttles, the product holders. And that's where we have the hygienic one, which is totally stainless steel, round. You can actually take it, put it in the dishwasher. And
Okay.
it becomes really clean, and you can put it back on the system and run again. So that's specifically for those applications.
Yeah, because it's a passive part, I understood. It's only like metal and magnets.
Metal
There's no-
magnets and encapsulated in stainless steel.
yeah.
So there's no electronics that can get damaged because of cleaning.
But what about the segments then, if I want the
I
hygienic
was
system?
expecting that question. So the shuttle is, you can see, it's totally hygienic. And the cool thing is because of the fly height, we can actually cover the segments with whatever material. Stainless steel, plastic, glass, as long as it's not
Magnetic.
Then it will influence the whole system.
Oh yeah.
Yes.
Okay, that's a good idea to cover it with, let's say, a thin metal sheet. But my experience is if you have a big plate like this, it would wobble. So how can we handle this?
No, you're right. That's one of the risky parts. And actually, what we have is a special feature where we can actually have, instead of this gap, which is now not there, we can actually have a gap up to 5 or 6 millimeters, where you can actually have a rib or something pulling down the cover sheet,
so you can fix it or
keeping
glue
somehow
it or-
a little tension, that it's always flat. And that's a special feature that we have in our system. And the cool thing is that the software compensates for that gap.
Yeah.
So the shuttles will just fly over, and basically they will have an offset of this 5 millimeters, but that's compensated in the position calculation.
Okay, so in this setup, I can see it's just mounted on a flat aluminum plate. I think that's good enough. That's what you need for mounting something like this.
Yeah, that's quite straightforward. So it has to be flat to some level.
Yeah.
It's not super high accurate plate that's needed. There's only 2 pins to lock in place and 4 screws to mount the segment.
Okay, so
Mechanically,
also
it's super easy.
it's quite simple. Let's say if one fails over time, it's not super complicated to replace it.
No, you only have to remove the cables. That's maybe also a good thing to explain a little bit.
Yeah.
At the bottom side of each segment, if you would flip it over, there is 2 cables for power. So power can be daisy chained from one to the next.
Yeah.
Then there is 4 cables for communication, which talk to each neighbor. So short branch cables. And
Okay, so you only have like 2. If it's a smaller system, you only have like 2 cables to the system, a power cable and a communication cable.
Exactly.
Okay.
And then we even prepared inside a water cooling channel. So in case you really have a high dynamic system that will heat up the motor a little bit, then we actually have a very efficient cooling system embedded inside the segment.
Okay, that's the 2 plugs.
It's the 2 extra plugs that
Yeah.
you see. Yeah, correct.
It looks like connectors for pneumatic
Pneumatics. It's the same type of connectors. Yes.
Yeah, okay.
You can actually have cold air flow through it or cooling fluids
yes.
to have even more efficient cooling.
You mentioned that there are different shuttle sizes, but what about the segment? Is it only this size that we can get?
No, it's not. There is multiple sizes, and one thing also important to mention that here we now see a 4x4 matrix fully filled with segments, but that's not a must. You can actually have holes in here. So as long as where you want shuttles to move, there are segments, and that's also why we have come up with different shapes. There is the rectangular one, but there's also a narrow long one. So you can actually have a process station, and you need some transport in between with another process station where you have multiple square segments.
Yeah, okay, so
for
we have squares
in-station
and
movement.
rectangles.
Yeah, and you can combine them in any layout, X, Y, Z.
Okay.
No, not Z, X, Y orientation.
Yes.
So if I want a process station like here, I could remove the segment and then put a robot arm here or something like that.
Exactly. Yeah. And then we also have a bigger size. So this is 240 to 40 millimeters.
Yeah.
We have same technology, same concept, one size bigger, 320 to 20. And that's basically price is almost the same, so it's basically more surface for the same price.
Yeah, okay. And same functionality.
Same functionality.
Okay.
Yeah.
So it's not
correct.
like there are any limitations on whatever you choose.
No.
Okay. How many kilowatts would this application use on a year?
That's an interesting question. I can tell you that the maximum power in each segment is 1.8 kilowatts.
Okay.
So if you would have it filled with shuttles, you would have them move like crazy.
Yeah.
Then you would consume 1.8 kilowatts per segment.
I guess it's very power efficient because
It's-
there's no friction.
Well, that's the cool thing. It's super power efficient because there's no friction. You stop the shuttle and you don't have any power consumption as long as the shuttle is landed. You only use energy when you're actually moving,
yeah.
and mainly when you're exaggerating or hovering at a high height.
Yeah.
So the constant speed, because no friction, is consuming very little power. So if we do the calculation compared to traditional technologies, we will always win.
Yeah.
For sure.
That's good to hear. Talking about stopping, we always need a safety system when we build machines. Is that thought into the system? Can we e-stop it somehow or safe stop it?
Yep, there is a safe torque off connection, so you can actually cut performance level dequalified
Yeah.
the driving power. So you keep the logic power on. So
Okay,
the
so
system
we
is
still
always-
have the
we still
like
have the
the
positioning.
position,
We
yeah.
still have, so if you move a shuttle by hand, you can see on the software that the position is changing.
Yeah.
All that logic power stays on, so it's very fast after e-stop reset. Switch on the safe torque off power, and it's immediately ready to run.
And is that for an individual segment? So I could just safety stop this one, and then this one could keep moving, and I could do my stuff I need to do here.
Yeah, you have to design it by basically the power cabling. So you can have one power drop that goes to multiple segments. They're all in the same safe torque up group.
Yeah.
If you then have an individual group,
Oh yeah,
you have a
make it
separate
like
power
groups.
branch.
Yeah.
Correct.
Yeah. So it's not the whole system I have to shut off.
No, definitely not.
I hope you learned something about ACOPOS 60. I know I learned a lot. Did you, Sverre?
A little.
That's good. And yeah, thank you to Hayo for coming as an expert and explaining us about this really cool system.
My pleasure. Love to be here.